Hello friends, so today we're gonna discuss how to print the top view of a binary tree. We will also discuss how to print the top view as well as the bottom view for the binary tree. I've also uploaded a video for printing the left side view and the right side view, so you can also go and check it out. So let's start. This question was not on LeetCode, that's why I'm doing it on HackerRank. So you know the question, you are given a root of a binary tree as an input and you have to print the top view. Top view means that when you look from the tree from the top, then what you'll see will be called the top view. As you can see, I'll tell you with the example to be more clear. So this is a simple tree. Okay, so what you'll do here is when you look from the top, you'll see this node, you'll see this node, this node, this node, this node. Like this 5 node is overshadowed, but how you'll know that whether this node is overshadowed or some other node is overshadowed or not? So what you'll do here is you'll find out the horizontal distances. So what I mean by horizontal distance is, let's assume that the root node is at a horizontal distance of 0. When you move from left of this node, then you are moving, you are decrement this value and you are decrementing it to -1, which means that you are on a number line. Let's assume you are on a number line, because when you print the top view, you will be printing a number line sort of thing, in which you will see this root here and then some nodes here and then some nodes here. It's just a number line. So how you can define here is, this is 0, this is -1, this is 2, and so on, -2 and so on. So what we are doing actually here is we are giving these horizontal distances to each node, and then we're gonna print them according to their horizontal distance. So this is -1. As we go to the left of this, we will make this value subtract 1 from its parent value. So it's -1. Then its parent is 0, so this is 1. Now its parent is 1, this is the right of this, so it becomes 2. Its parent is -1, it's left of it, so it's -2. Parent is -1, it's right of it, so it's 0. So when you look from the top, as you can see, you will only see the nodes which are on the diameter, or let's say all the inner nodes will be overshadowed, because as you can see, when you look at from top, this also has the same distance, but this node is above it, and thus you'll only see this node. But when you look from the bottom, you will not see this node, you will see this node, this node, so you will see -2, this -1, this 0 node you will not see, you will see this node, then you will see this node and this node. Okay, so what you will initially first have to do here is, you will first find out the horizontal distances of every node. You will just do a O of n traversal over the whole tree, starting from the root node, and you will initialize a root node with 0 distance, and whenever you move from this root node or some other node to the left, decrement its -1 from the root node value, and if you go to the right, increment its 1 with its node or parent value. Now you have a map, you can create a map of all the nodes with its distances. Now how you will know what you will see from when you're looking from the top? So what you'll do, you will do a level order traversal using a stat. I have also posted 2 videos on level order traversal, you can go and watch them out also, but I'm going to discuss this in this video also. So you'll actually do a level order traversal of this tree, and whichever node or whichever distance you will find first, you'll update it, and you will, whenever you find the distance again, you will not change it. Okay, whenever you are looking from a top view and you hit the distance 0 first, you know that whenever the distance 0 will come again, we will not change it. Why? Because we are looking from the top, and when we are moving in levels, the first level or the distance we have seen is the one which we're gonna see from the top, because this, if we again see this value, it will definitely be hidden or overshadowed by the top values, because we are moving in level order, and thus we will move in level order traversal. Like as you can see, we will see -1 for the first time, so we will update minus that. There is a node whose value is 2 and which is at a distance -1. There is a node which has value 1 and which has a distance 1 and has a value 3, and so on. So we'll update this another map which has distances along with the first node we have encountered when we are doing our top view. And now you're gonna ask me how we can update for the bottom view. We'll do the same. We'll make a map but we will not stop updating it whenever we'll hit the first value, because in watching from the bottom view, the last values we're gonna update is the bottom view. So as you can see, when we are looking on the top view, whenever we see a new value, as you can see, whenever we are moving on level of traversal and we see that we have first encountered distance 0, so we will make distance 0, and whatever node we have seen there, its value 1, we'll update it. But in bottom, or when we are looking from bottom to this binary tree, whenever we again see this 0 value, we will again update it with this new value, because the bottom most value which we gonna find out and we gonna update it will be actually the defining us the bottom view for this binary. So that's the core difference between how we're gonna change for the top view and bottom view. For the top view, we will only fix that value whenever we find the distance. We have seen this distance for the first time, we're gonna update this value and we're gonna not change it again. But for the bottom view, whenever we find a distance, we're gonna change it up until we're gonna travel this whole binary tree. So that's the whole logic, as well as if we're gonna move down to the code part now. So this is the code I've written. So first we're gonna check that whether the root is null, we just return out. Then what we'll do, we have made a map for, we're gonna store what is the horizontal distance for each node. So for the root node, the horizontal distance is 0. We're gonna update this in this map, and then we're gonna travel the whole tree starting from the root and initializing its value distance with 0. This is a global map, so we're gonna travel the whole tree. Whenever there's a left child exists, what we'll do, we will first update its left child value with this distance, because the left child value is just this parent distance minus 1, and we're gonna again travel this tree for the left value. This is a recursive function. We're just traveling the whole tree. And same for the right side. If the right child exists, we're gonna update this right child distance in this map, and we're gonna travel this right child with this new value n+1, and we're gonna return after we have traveled the whole tree. So now we have updated the whole tree with the root, like with the nodes and its values. Now we're gonna make a map with view, which will store what is the value, or what values we have seen for the first distance we have encountered. And we have also made a queue. Now, because in the top view, the 0th value or the 0th distance is just the root value. Okay, so what we'll do, we will update the root value, the root data, and we will update this view map with the 0 distance. We're gonna push this root in this queue, and we're gonna move until this queue become empty. We're gonna pop out the first value from this queue. We'll check that for this first value whether its right child exists or its left child exists. If its left child exists, what we're gonna find out is, because its left child exists, we're gonna find out what is the distance for the left child. Okay, what is the distance? We have stored the distance in this map for this node, for left child node. We're gonna see that whether this distance we have encountered earlier or not. So what we'll do in this view map, we're gonna check that whether we have seen this distance earlier or not. We're gonna use this count function, and if this count is 0, which means that we haven't encountered this distance yet, what we'll do, we will update this distance with the value which we have seen, the data of the left child, and which will push this left child value in the queue. If we have seen this value earlier, we will not do anything, and we will just push down this current left value or the left child in the queue. Same will do for the right child. We will check that whether the distance we have seen here on the right child, we have seen it earlier or not. If we haven't seen this earlier, we will update this distance, because Whatever the first distance we have found, we will update this value and we will come to the next value. After this, because the map stored them in the increasing order, so the second value, because the first value is the distance itself, the second value is the data. So we will iterate over the whole map and we will output the second value, which is telling us the top view. If we want to print out the bottom view, what we'll do, we will just delete this if condition. And whenever we found any distance, we will just update it in this view. If we just remove these two if conditions and then the whole value or this code will print out the bottom. I hope you understand both of the codes and the logic. If you still have any doubts, please mention down. Thank you for watching this video. I'll see you in the next one. Keep coding. Bye.